Hi, I'm Tom Woltich with Sun Microsystems. I'm here to show you the SL8500, our latest enterprise tape library. It has many innovative features, but some of the primary design objectives were to make consolidation simpler, to provide the highest availability possible, and to minimize your environmental cost. Let's take a look at the back first to show you how we do that. Let's start by talking about the tape drives. The first thing you'll notice different in the SL8500 is the drive bay is built in. There's a few good reasons to do that. Primarily, it's so that you can add drives without taking an outage. So you no longer have to trade off slots when you add drives. So you can scale up to 64 drives in one 8500. I'll show you the pass-through a little later, but for now know that you could attach the pass-through hot, so we can scale past 64 drives again with no outage. That gives you maximum availability and uptime and minimizes schedule outages. In the past, the drive bays were always something that bolted on the side of the library, so adding another one of the drive bays required shutting down a library. The next thing I'd like to point out about the drives is we're true mixed media. Any drive can go anywhere. So we have our high performance, high capacity T10000 drive for the enterprise. We also have our fast access 9840 drive and our 9940B high capacity drive. All of those are available in native fiber channel as well as native FICON interfaces. We have mid-range drives, HP and IBM LTO drives with native fiber, and finally Quantum SDLT drives with native fiber. Any drive can go anywhere, so any combination will work. The reason we did that is for consolidation and also for flexibility. You have the most flexibility going forward since it doesn't matter what goes where. I'll show you on the front how we do that with the cartridges, how anything can go anywhere, but in the back any drive can go anywhere as well. Another design objective of the SL8500 was high availability. So we've already spoken about how we can add drives while it runs. The other aspect is to try to eliminate unscheduled outages as best we can. So if you're trying to design a product that has the highest possible availability, you want to try to find what can break and either design it out or make it hot replaceable. So the primary culprits of what can break in a library system are the drives, the power supplies, cables and connectors, and robotics. We'll cover the robotics when we're in the front of the box, but now let's start with the drives. Each drive is actually completely hot replaceable. So should the drive fail, we can replace it with another drive. When we plug it in, the library has dynamic worldwide name. What that means is that this port has a name that's given to it by the library, so when the replacement drive is plugged in, the library will shoot the worldwide name to the replacement drive so you don't have to reconfigure your software. As long as your application software uses worldwide name, we can replace a drive without reconfiguring. The next thing to talk about in terms of reliability is power supplies. The SL8500 is designed to actually run off of two separate AC grids. Should one of them fail, the entire library will continue to operate normally, all the drives, the robot, and the electronics. In this case, we didn't even install the second AC connector. Those AC grids feed these AC to DC power supplies. These are the power supplies that take care of the robots and also the drives. They're all redundant, hot replaceable. If one of them fails, we can take it out and replace it. The whole system will continue to run. How is that different? Well, in the past, we actually had the power supplies on the drive tray. What that meant is if a power supply died, that drive was down. Moreover, since the power supply was on the drive tray, you had an AC input on this drive. So you would take typically half of your drives and connect to one leg, half to the other. If you lost an AC leg, you'd lose half your drives. Now you can lose an AC leg or not even install it, everything will run normally. You could lose a power supply, again, everything will run normally. The last piece on high availability I wanted to cover in the back of the machine is cables and connectors. So we tried to greatly reduce the number of cables and connectors in the 8500 compared to previous libraries. So for example, the Powderhorn library that it replaces had 12 printed circuit cards just in the library control unit attached to the side of the silo. There's additional electronics inside and additional electronics in the library management unit, and then that was all connected by a series of cables. That was all shrunk down in the 8500, condensed to this one single card here. So all those cables and connectors that can fail are gone. This card offers single or dual TCP/IP connections to the host to provide TCP/IP failover. And then the other thing I should point out on cables and connectors is every library, including our powder horn, had a flex cable and a connector on it so that we could control the robot. As you'll see on the front, the 8500 has no cables or connectors running to the robots. They're effectively untethered because we modulated the power rails that the handbots are running on. Also in the rear of the machine, you can get up to 4 6U racks. These allow you to install hubs and switches so you can cable from your fiber drives before you run out of the library, saving you some floor space elsewhere. Lastly, I'd like to point out that the width of the SL8500 is only about half that of the powder horn. I'll show you how we were able to do that on the front of the machine.